We are looking at a line here, and you can see that this line has an x-intercept marked x. That's where it intercepts the x-axis. All right, this is the x-axis here, and the line crosses through that at x. And over here we have a y-intercept. It's called that because that's where it crosses the y-axis, right? So here is the y-axis going vertically, and where you have the line meeting with this axis is this point here. That's y. So x-intercept over here, y-intercept over here. I want to move these around a little bit to make a point. So you'll notice over here you can see the coordinates of x and the coordinates of y. I'm going to start by moving x. So as I move x around, keep your eye on this coordinate here and see if you can notice anything interesting. Okay, so I'm just going to grab x, drag it around. Do you notice anything interesting about those numbers? Hopefully you notice that no matter what I make x equal to, no matter where I put that x-intercept, the y-coordinate here is always 0. What do you think is going to happen when I move the y-intercept? So let's say I'm going to take the line and move it around so that y is going up and down. What do you think is going to happen to this coordinate over here for y? So keep your eye on that. I'm going to move point y around, and hopefully you notice something interesting. Okay, so this time, no matter where I put y, as long as it's the y-intercept, you'll notice that the x-coordinate here is always 0. So the key information I want you to take out of this is that when we're looking at the x-intercept, which is where the graph crosses the x-axis, y is always equal to 0. And then similarly for the y-intercept, which is where the graph crosses the y-axis, x is always equal to 0. Right? This is the key piece of information. Now, why am I telling you this? I'm telling you this because it's going to help you draw graphs of functions a lot easier than making a table. It's a really fast way to graph functions. So we'll do a couple examples now. So here we have a linear function, and we're going to do two things with that linear function. The first thing we're going to do is find the intercepts, and then the second thing we're going to do is draw a graph. Just like we talked about, we know that whenever there is an x-intercept, that means that y has to be equal to 0. All right, and we know that every time there is a y-intercept, that means that x has to be 0. So x-intercept y is 0, y-intercept x is 0. You can remember that those opposites kind of match up with each other. Okay, so we can actually use this information in the equation here. For the x-intercept, if y is equal to 0, that means when we look at the equation, this y, we can rewrite that as 0. So instead of writing this as 4 times y, we can write this as 4 times 0, and we get something that looks like this. So let's see, 3x plus 4 times 0 equals 12. Well, 4 times 0 is just 0. That's a really easy calculation to do. So this equation really means that 3x is equal to 12. And if 3x is equal to 12, then that means x has to be 4, right? 12 divided by 3 is equal to 4. So that means the x-intercept is 4, because when y equals 0, x is equal to 4. We can do the same thing with the y-intercept. So the y-intercept, x equals 0. So then when we look at our equation here, instead of writing 3 times x, we're going to write 3 times 0. We're going to substitute 0 for the x. So we get something that looks like this. 3 times 0 plus 4y equals 12. And again, 3 times 0 here, anything times 0 is 0. So if we simplify this equation, then we end up with 4y equals 12. And if we want to know what y is, we have to divide by 4. We have to cancel out the multiplication by 4. So 12 divided by 4 is 3. So that means y must be equal to 3. So in other words, the y-intercept is 3, because when x equals 0, y equals 3. Now, this is a great situation because if we need to draw a graph, all you need to graph a line is 2 points, and we have 2 points. We have the x-intercept and we have the y-intercept. So let's see, the x-intercept is at x equals 4. So if I'm on the x-axis here, I count 1, 2, 3, 4, and that's this point here. The y-intercept is y equals 3. So I find the y-axis here, and I count up 1, 2, 3, and that's that point there. So then the last step is just connecting those 2 points using a line. And that's a nice easy way to draw a graph of that function. Let's do one more example here. So we have a new equation this time. 2x minus 5y is equal to 10. And we're going to do the same thing. We're going to find the x-intercept, the y-intercept, and then use those to graph the function. So x-intercept, that is the point where y is equal to 0. So we can start with that. We're just, again, we're going to make the y in this equation equal to 0 and then calculate what x is. So instead of 2x minus 5y, we can write 2x minus 5 times 0 is equal to 10. 5 times 0 is 0, so this is just 2x on the left-hand side. So if 2x equals 10, we can divide by 2 on both sides, and we get that x is equal to 5. So that means the x-intercept is 5. Before I forget, I'm just going to graph that point now while it's fresh in my mind. So I find the x-axis here, and I count 1, 2, 3, 4, 5, and I'll just mark that point. Okay, let's do something similar but with the y-intercept. So again, y-intercept is the point where x is equal to 0. X is equal to 0. So instead of 2x minus 5y equals 10, we're going to write 2 times 0 minus 5y equals 10. That's our substitution step. We substituted 0 here. All right, easy calculation. 2 times 0 is 0. So got to be a little bit careful here. This negative sign goes with the 5. So what we have left on the left-hand side is negative 5y equals 10. All right, well, if we want to solve for y, then we have to divide by this negative 5 on both sides. And 10 divided by negative 5 is a negative 2. So y must be equal to negative 2. Okay, well, that means our y-intercept is at y equals negative 2. So I find my y-axis, and I count from the origin, I count down 2, negative 1, negative 2. I draw that point there. And now because I have these 2 points, I can connect them with a straight line and I'll draw my linear function. So this line is what's represented by this equation.